Uh, so I'm going to pick up where we left yesterday with the classes, and I'll be showing a couple of more stuff. Today we will be talking some TypeScript actually. Okay. And I'll show some new stuff, some new syntax. I'll show how you can inherit from a class. I know that you will not be like really needing this, but this is something that I would like to show you as part of this course. But anyway, we'll not be going into the depths of how things look and work. So I'll just show the syntax. I'll show an example, and I'll show a couple of things that you might actually use. But extending classes, etc., wherever it is, I'm not sure if you will be using that much in Cypress course or in your day-to-day job. But anyway, just so you know that there is something like that. I'll tell you that too. So what we have here is we have a class, right? So as you recall, classes are these blueprints, and we use these blueprints to then create our buildings, which in our case are our objects. So in the classes, we define the properties, the keys of our object. We define how the object should behave or can behave, or what kind of functionality we have. So in our classes, we can have methods, right? So the functions in classes objects are called methods. So we can say that our human being can speak, they can usually walk, right? So they can do something. And there are many other actions we can assign to a human being, right? And there are many other properties that we can also assign to the human. But what we have here is we simply have that the human has hands. It needs four, but disregard this because I just was testing something and they didn't forget to have to change it back. So our human beings usually have two hands. I'm not trying to make any assumptions how many legs and hands humans usually have, but okay, I'm just trying to draw a picture here. So no offense to anybody. Okay, let's imagine humans have two hands. They have two legs. They usually have a name, right? And usually they can speak and walk and whatever other methods or human abilities. Okay, not human, but human abilities. Cool, I got it correct at least. And we have our constructor function, right? So as you can see, the name, I did not assign anything to the name property because that's normal. I do not know, or no one knows everybody else's name, and we cannot kind of guess the name unless we know the name. So that's why the name is empty, and I'm using some TypeScript here to designate that the name property is a string. We could go for number, whatever it is. However, we know that the name of the person is a string, so it made sense to have it as a string in TypeScript. So this is TypeScript stuff. Now, we do not have to say that human hands is a number because we immediately assign a numeric value to these properties. Hence, TypeScript, as you can see, can infer from the initial value of these properties that the type of these properties are numbers. So that's why I don't say number. I can, but we can omit this part. We immediately assign some value to the variable, to the property. Hence, TypeScript knows that hands is a number. So we can just go the shorter way. Now we have the constructor, right, where we receive this name, the value of the name, which is string. I could go for something like this, right? And in this case, as you can see, it says name is any, basically, which basically means that name can have any a value which is of any type, right? And as you can see, TypeScript warns that the name implicitly has an any type. Okay, but it's better to either assign a value or specifically say to tell TypeScript the type of that property. Actually, this is by default, I think this is a warning. However, in TypeScript configuration, you can in the tsconfig, you can set some kind of property which will disallow the usage of any. So whenever the TypeScript compilator occurs any of these cases where the type of the variable is any, it will just give us an error and say you cannot use any. But since we have name string, it's okay. So basically expect to receive a string value in the constructor, and we assign that value name to this dot name, which is this property. Okay. And we have our usual speak method, which we have from yesterday. And the walk method is basically empty. It doesn't do anything right now. But we'll do something with this. I think we shall see. Okay, so the way we can kind of play with this, we can maybe create a human being, right? Being, and the way I now create this building, this object from the blueprint is using the new keyword. So I say new human. And then I need to provide the value in the constructor, right? Which is the name. So I would say calling, for example.
Right.
Okay. Now if I console log our human being, okay? Now we'll say an object and we'll see an object which has three properties: hands, legs, and name, which is kind of expected. That's what we have here.
Okay. Here's how to methods.
Yes. Now the methods are not part of the object, but however they are part of the prototype. The reason of this is, imagine you put that method inside the object, and then you create 1 billion human beings. That means that these methods are part of the objects themselves, right? But speaking is some kind of general thing which is assigned to all the objects. So usually, if I would do, let me do it the functional way, and you'll see. So the analog of this thing, of the human class, if I would write the obsolete way, would be something like this, okay? Human, we would say name, okay? And then I would say this dot name equals to name, this dot legs equals to 2, this dot, what was that? And of course, equals to 2. Yeah. And also I could say this dot speak is a function which says, function which says console.log this dot okay, I could do this, and yeah, whatever, human one. Never mind. Name collision. I could do this. Then I could create a new human one, and that would work. And this would work. However, notice that the function is part of this object. Okay. But this function, as you can see, has nothing very specific to do with the object itself, right? It just console logs this name, and any of the objects that are instantiated with the new keyword will have this dot name, right? So it means I'm creating a local function which does something that is general. That can be done for all the other objects. But now this function, this method is part of that object, which means the size of the object in the memory grows. However, there is a way to do this in a more optimal fashion. So that the more optimal fashion would be, as we discussed yesterday, we can assign that underscore proto property to another object and have all those links, right? So that link, you can think of that link of the prototype of the object. So if I say, just think of it this way. So the proto, well, let's have an object, proto underscore, which links to another blah object. So we can see that this object, which is assigned to the proto property of the outer object, so this is the prototype of this. We can put it that way. Now, what the prototype means is that when we try to access any key of this object and we do not find that, we will look that up, in the prototype. Okay, so think about the prototype that way. So now what we can say is we can say, get me humans prototype and add this method to the prototype. Okay, and when we remove this method, and then we try to human one, and now when we try to access the speak method on the human one, since the speak key or property is not part of the human one class or function constructor, we will have to look it up in the prototype. And now it appears that this speak function is defined in only one place, right? Because all the human one, all the instances of this class human one will refer to the same prototype. So the prototype is the same. All the instantiated objects will refer to the same thing. So the way we can imagine that, let's say class human one, right? And or object human one, prototype of human one. Okay. Now we have many instances. So objects are instances of classes. That's the way we say it. Now all these humans will refer to the same prototype. Okay. And this one, and this one, the other one, and this one. Now the interesting thing is that this human prototype now is only defined here, right? As part of our prototype. Now, and imagine we have many other objects of the human one class. Now, since this speak method is defined here, all of them will, if we try to say human one.speak, now we will have to look it up in the prototype, but not in the object itself. So this is an optimal way. This is usually the way you would add your methods, because again, when you try to say .speak and we don't find that speak property in the object itself, we fall back to looking up it in the chain, right? So that means we can define this method only in one place and have all the objects to come look it up in that place. So this is a more optimal way of doing things. The other way would be to have the speak method defined in each object, right? So that means that we are using more memory, doing more stuff. So that's not a very optimal way of doing things. Of course, you can do that, right? So you can say this .speak function, whatever it is, you can say that. However, now it means that this .speak is now part of the object, but it usually doesn't make sense to have the methods as part of the objects. So that is why you do not see the speak method as logged in this console.
It is, but when we use it's the ones that you explain, the way you explained in the beginning of the lesson. It is becomes the same like this one, but this one is obsolete.
Now, as I explained yesterday, this class syntax, which was added in 2015, this is something called a syntactic sugar. What syntactic sugar means that now you do things in a nicer looking way than previously. Now, previously you would have to do all these functions. You would have to add your methods on the prototype, right? Not on the class. But they added this class syntax where you can add your properties, you can have your constructor, you can have your methods, all of them defined in the class in one place in a nicer way. So the syntax is nicer. However, under the hood, you cannot escape JavaScript. So they did not like natively implemented this object-oriented programming way of classes, but they just added the class syntax. So you can have a nicer, more familiar OOP class syntax, but under the hood, it still kind of falls back to this stuff. There are some new additions like private properties. So in JavaScript, if you would just add a hash before your property name, that would become a private property, which means you could not do the hands. As you can see, even if I type dot, it usually gives you everything that you can do after the dot. As you can see, the hands is not there anymore. Okay. If I remove the hash, I was actually going to get to this point, but anyways, since we have the question, now if I do the dot, as you can see, hands is there, which means you can access that. Now, if I access that and do console log, we'll see 2. And now if I add the hashback, which means this is a private property, which means you cannot access that with dot. Let's put it this way, okay? You cannot access it with the dot. Now we have an error. It says property has does not exist on type human. Now this would be a legitimate JavaScript error because this is a JavaScript syntax, which was added like recently.
So when we create the human being using the class human, then another human being is created with properties, but as a method, there is the human class left, and is this way the human class is a prototype of human being. Is it correct? Or it's where's the methods in which prototype?
So to maybe see that, we can, I think, console log the proto property and let's see what it gives us. So it gives us an empty object. Now, where these actual methods are, well, I would say in the proto, but in this case, as we can see, the proto is.
So human being has after issues be a class has properties and also a proto link, and in this and the prototype inside.
So again, they are in this prototype property. Okay, so I've defined the human class called human. Now this again comes to my point where that class is a syntactic sugar. Now again, we have this speak method defined. We have a class, then we have the speak method. Now what I did, I console log the human.prototype.speak, and as you can see, it is a function. So the speak is defined on human.prototype. And as I just showed, if previously, before 2015, if we would to implement this human class, human, we would do this dot name, we would say, and then we would say human.prototype.speak equals to function console.log this.name. So now, as you can see, previously, before 2015, before the class syntax, I would have to kind of specifically say that human.prototype.speak is this method. Now, however, with the class syntax, I just defined my method speak in the class itself. I never said human.prototype.speak equals to this. But as you can see, when I do the console log human.prototype.speak, this is actually what I get. So you can think of the class syntax as a nicer way of doing this. Okay, so it's basically kind of, it's not 100% the same. Okay, but you can think of class syntax as a nicer way of doing this, as we can see here, because we have the class, then we do human.prototype.speak, and we can see that our method speak is logged. So that means that human.prototype.speak was created for us, and previously with functions we would have to create that method kind of manually by hand. Okay, any other questions?
Good question about like yesterday's example that we were discussing, while having two objects, and like for each, like the other is proto, or like that case.
No, I didn't have.
It's like giving infinity, so it's giving infinity loop. It's giving proto.
I don't think it's an infinite loop.
I
think it's just overriding. I think it was discussed during the lesson. I mean, at the end of the lesson, I think the prototype changes gets overridden, because we would link person to speaking person, then we'll link speaking person to person, and I think that the prototype changes gets overridden.
After the infinity like concept is
There is no infinity there. We'll get an error if there was an infinity. If there was a cyclical loop, and if you try to access something, we would get any kind of error. It's the same with the recursion. So when you infinitely call a function in a function, your call stack is actually a finite structure. It cannot, I think, hold more than 65,000, whatever the number it is called. So if you have more than 65,000 whatever items in your call stack, JavaScript engine will give you an error and will say you have too many things in your call stack, so I cannot continue adding more things. So if there was anything infinite, I mean infinite calls, infinite whatever, we would for sure get some kind of issues. Okay, so the engine wouldn't allow us to overflow all the memory and crash the computer. Okay. Yeah. By the way, regarding the hash syntax, right? Yeah, I just did a console log, so it did not give a JavaScript error, but it gave us undefined. So let me just demonstrate that. So human being dot, if I say hands, right? So hand is a private property. I'm just answering the question. We don't know what a private property is, but it just returns undefined instead of an error. So if I would remove the hash, now it get to.
Described in the home.
Pardon?
Private properties not described in the home.
We did not have homework, but we have learning material.
You sent us the link.
Yes, so the first one. Okay, so what I have here below is another class which extends our human class. So let's maybe remain this into human being, right? Belong. Okay, and not press enter, I guess. Belong. Okay. Cool. So we have another class which extends our human being. Well, person who extends human being. At extending in JavaScript means we basically inherit the properties, we inherit the methods, etc. So we have access to all these in our person class. Okay. So let's start with kind of the simple version of this. Okay. So we can do this. We can just say person class extends human being, which means now we can create a person. Person equals new person, right? So we're instantiating a new object of the class person, And as you can see, it expects to get one argument. Now, we did not do anything else. We just said class extends human being, but still TypeScript knows that we should provide some argument to person, but we don't have a constructor function in the person. And that's where the inheritance comes. Since we inherited everything from the human being and the constructor is still there, hence we should expect to pass a variable. So if we do vartan, now we will have a person named vartan. We console log that. As you can see, we get a new object, and we can also say person.speak on this, and it still works. But as you can see on line 25, I did not write any constructors. I didn't write the speak method. I didn't say the person has hands, legs, name. That this all comes from the extend keyword, right? So when we say the class person extends human being, that means all the properties, the constructor, the methods, everything is being inherited from the human being. And so we can call all that or use all that in the person. And in that sense, if I would say person.legs, we would get 2 because we extend that value from the human being itself. Now, what if I would like to do something else in the person? I would like to, for example, the speak method, I would like the speak method to be different. So that's where we can do we can just basically override the speak method, right? So I can say now console.log this.hands, this.legs, and this.name. So we can do this, save, and now as you can see, now let's just type also the speak method of person. So now, as you can see, we can override, right? So we can override the original speak method. Now, when we say person.speak, this new method actually gets called and not the old one. Okay. So let's see if we can maybe also call the original method, right? Now, it turns out we can actually do. So in your inherited classes, you can do super dot, and super would refer to the parent class, right? So when we say super.speak, that would mean call human beings speak method instead of doing something else. So what we do in person speak, we call the original speak method via super.speak, and super means call human beings speak method. And so we call that, and we can do anything else. So that would be the way to call the original classes method, which we're extending from. Okay. So let me remove this. Now I had some comments there. Let me just bring them back.
Just like in practical, which cases we are extending classes, or like, can you bring an example?
Yes, customizing functionality. Last session, yeah, if you remember that Psi example that I brought. So extending would be the way to do that, not actually overriding the proto, whatever it is. So you would say custom Psi extends my Psi, and your Cypress instance would have some functionality, and then you can customize that in your custom Psi or whatever it is. So that refers to pretty much all the classes that there are. Now, again, I don't think you will need this extension stuff too much, but just to let you know that there is something like this, I'm letting you know about that. Now, again, as you can see, now basically the code we have right now here, it is basically the same as this. So if you just create a new class which extends another class, but don't do any kind of customization, you can simply say like create a class, an extended class from human being, but don't do anything custom. This is pretty much the same, because now you explicitly create a constructor in your person and say pass all the arguments to my original constructor, which means it's basically the same. So if we would create another const person equals new person and person.speak, this would still work. So okay. Now, what if I would like to create some kind of property on my person class, which is not accessible by the outside world? And in TypeScript, we can use this private keyword, which means that this new property, profession, is private to our person, which means it is not accessible from the outside world. And of course, we're looking forward to also instantiating a value there. So we can say profession. Oh, sorry. So this should have been a column. So profession, and this is a string. Now we pass our name to our original constructor. As you recall, the constructor of human being only expects to receive a names. Hence, we pass the name to our original constructor, but we add our profession in here. Right, so we say this profession equals to profession. Cool. We could do this dot name equals name, but this is not the 100% correct way, because calling the original constructor is actually the correct way, because maybe you are doing also something else in your constructor, blah blah blah, whatever it is. So just remember that when extending your classes, you should be passing your arguments to the original constructor. Okay, so we added new profession. Now yeah, of course, we expect to teacher and school teacher. Now, of course, our school teacher can speak. However, when I try to console log our school teacher's profession, and again, as you can see, similar to the hash syntax we have. Now, when I try to say profession, it's not there. So profession, right? So now again, TypeScript gives the error. It says that it is private and only accessible within the class person. What if we suppress this thing? If we suppress this error, we will still get the value, which means this is not the native JavaScript private thing, right? Because with the native JavaScript private thing, if we would do, we would get the undefined. So this private keyword, right? So this is the new native way in JavaScript to say, this key only belongs to person, and it cannot be accessed from the outside world. You cannot say dot profession or dot whatever it is. So you cannot do that. This is the JavaScript syntax. This is an actual JavaScript syntax. Now, when we roll back to the private keyword, as you can see, is when I suppress the TypeScript error, we still get the value, an actual value, which means this private keyword is different from the native hash profession syntax. And this is one of the dangers of suppressing TypeScript errors, because in this case, we say, we don't need you to show any error. We know what we're doing. However, we are taking into account that this property is private, and we're building our application around the assumption that it's private, it's not accessible by the outside world, and now it is actually accessible outside of the world. So we may come around some kind of logical even errors. So it's this is one of the dangers of using the TS ignore. So use it only when you actually know what you're doing. And if I would remove that comment, Now TypeScript would just say, this is an error, you cannot do that, and it would not usually allow to build the application.
What should we use as a
Bash.
is it
Bash.
bash or is it word private?
So I've never seen the hash syntax to be used in Service Titan. I actually haven't seen this used too much because it's a new syntax, and you don't usually do that much of OOP in JavaScript because we don't have OOP in JavaScript. It's just a class syntax. So I've never seen it used too much nowadays. In TypeScript, you would just use this private keyword, and since TypeScript will show you an error or TypeScript will not allow you to build your code, you are kind of on the safe side of the things. Okay, so again, now this private keyword, which is a TypeScript keyword, a TypeScript thing, rather. So if we would not like our properties, our methods to be available in the outside world, right? So if we would not like profession to be available when we say schoolteacher.profession, we can do that. We can say it's a private property. But however, we can access our properties in our class. So we can do something like this: tell profession. Okay. So we can say console.log this dot. Now, as you can see, it is accessible here. So now what I do, I can say tell profession, and we get undefined, of course, because tell profession returns an undefined, and I do console log, so I would need to remove this, as I was calling a completely different thing previously. Teacher. Okay, one of the use cases of private properties would be you receive raw data in the property, and usually the value of that property is not that useful for the outside world. One such example would be, for example, again, the profession, right? So we can create a profession like this, right? So, and we don't want the outside world to receive the profession in this, but we would like to do some formatting, some validation, whatever it is. We can use the getter for that, for example. Getter, and we can say return this dot profession at 0, which does what?
Profession.
This profession dot add 0. What does this code do?
We code. We get it already first.
Not a change. What does this code do? This dot profession dot add 0.
Returns the first character.
Yes, it returns the first character of the profession. So what I'm going to do, I'm going to say to uppercase, which means uppercase the first character, and then add the all of the rest of characters when I do slice 1. This dot profession slash, yes, I had a typo there. Okay, nothing changed on the tell profession. Now, when I say console.log schoolteacher.job, now I will get I'll get the T formatted for me. However, as you can see, the A is still there, and to fix that, I would need to job to lowercase everything first, right? And then build on top of that. So I will do this, and I will put a new line here for the readability, and now we have it fixed. So an example here was that the user can specify, can send anything as the value of profession, and usually it's not the way we would like to save the profession in the database, or this is not the way we would like to show the profession on the user profile page, whatever it is. We would like to do some validation, some formatting. So that's why we can make this profession property as private, so it is not as accessible from the outside world because it contains user data, which can be messy. We did not validate the data. So we're adding these kind of guards around the profession, and we can then use schoolteacher.job. By the way, this get, as you can see, this is a function declaration, but when you put this get keyword before the function declaration, you can access it as a simple value. Okay, so we could also do job, and I could call this as a function. I would still get the same. But if you would like to access this job as a property, but not as a function, you can just put get, and whatever is returned from this job getter, this is called the getter, you can just access it as a property here. Okay, so we do not need this tell profession here. I'll remove this. And that's about that. Also, another thing could be, I don't know, maybe validating the age of the teacher. Okay, so we can have private age, and we'll receive the age as a number, since it is a number. This dot age equals to age. Okay, and then we can say, or let's say person age. Okay, person age, so that we use the nicer. Okay, so another thing I can do, I can say age, and now I'll kind of try to validate the age value. If this dot person age is greater than, let's say, 18, okay, and this dot person age is less than 68, return the age. Okay, otherwise return none. Make sense? So now let's say, I don't know, 35. We have a school teacher who is 35. Now when we say console.log, school teacher dot, as you can see, we have age, but we don't have the percentage. We have an age. So I say age, and then I will receive 35. But when I say 78, I will receive a number. Okay, makes sense. So you have you have your private properties, which basically contain raw data, or you simply do not want them to be accessible in the outside world. There are multiple use cases. So two of them will be, you simply do not want your property to be accessible from the outside world, whatever the reason is. That is up to the developer, up to the project, up to the task. So we can come up with multiple examples how to do that. But one of the main purpose of the private keyword is do not make this property or function accessible from the outside world. Now, and doing this validation or formatting were two kind of use cases where I showed how you could maybe use private keywords. But again, these are not the only ways you would use the private keyword. There are many other use cases and ways to use them, and it depends on the application, your task, your job, whatever it is. So just know that you can do something like this, and then when you have some kind of task, think of private keywords. Can you use a private keyword? Can you use a getter, etc., etc. Okay, so let's do some 10 minutes of break, and let's see what will be next.